Now we will look at different options to combine plots. So, for example, if you want to create a panel of plots for publication, so one way is to create each plot separately and independently and then combine them later, for example, with packages like ggpopr or Patchwork. Or you can create multiple similar plots in a panel with facet grid or facet wrap. So here are 3 different plots I want to combine for the Gapminder dataset. We have one box plot, one line plot, and a scatter plot. And we can use the ggpopr package and more specifically the ggarrange function, where we just write the 3 plots, plot 1 to plot 3. We want to have a common legend for this, but because every time we color by continent, and we want to have the legend at the bottom. So you see here that we have a common legend for the color, which basically combines the plots, the box plots, the scatter plot, and the line plot. We want them to be in one row with different width. So the scatter plot here gets 40% of the space, and the box plot and the line plot get 30% each. And we have labels ABC to label these panels. Of course, this plot here is not perfect. You need here a bit more space for the x-axis labels. The title is a bit cut off here and so on, but in principle it's really easy to use ggpopr to combine these plots in the end. A different option is Patchwork, which has a bit of different syntax. So you basically take the plots and can define here with a vertical bar or with the slash how they are combined. So here, for example, the A and B plots are next to each other, and then in a new line or in a new row, you have here the third plot. Here for the first 2, I removed the legend, so that is here on the bottom here in this case. Again, you see here the legend is cut off and so on, so it still has needs some improvement, but it's also quite easy to combine plots. Now we have a look at facet grid and facet wrap. So again, here we will use the scatter plot with the GDP per capita on the x-axis and the life expectancy on the y-axis, colored by continent. And we can use the facet wrap function, which will produce, as you can see here, one plot for each continent, because here in the facets we defined the variables continent, and we defined that we want to have 2 rows, 1 row, 2nd row. And with that, it produces a panel of plots which is separated by the continent and therefore also separated by the color, basically. What you can do is to use the option scales 3 to have different axis limits basically for each of the plots, because it makes it easier for example, here for Oceania and so on, to get the different data points. Yeah, here before it was really cramped together, and here you can get a bit better overview which life expectancy it actually is. You can also use facet wrap with 2 variables. In this case here, continent and year means it does even more plots separated by the combination of continent and year. If you use the label both option for labeler, it will also label here not only the value of the variable, but also the name of the variable. So without that, we would have here Africa 1997, which of course would be also understandable, but to be clear, we write continent and year in front of it to really be clear about it. Facet grid is another option which is a bit more practical if you want to have multiple variables faceted, because you can define which variable goes into the columns and which goes into the rows. So here you have also the continents, and here you have the years. So you can directly see this panel here belongs to Africa in the year 1997, for example. And the cool thing about Facet Grid, for example, is that you can use it just as an element in ggplot, but if you add things like, for example, a horizontal line, it will appear in each of the panels. Or if you have a certain theme set, for example, theme black white, it will automatically be used for each of these plots. So besides that, there are also many packages that extend ggplot2. So there's this website here with 151 registered extensions for different kinds of things. You see here Patchwork, for example, ggstatsplots, which has a bit of enhancement to ggplot with giving statistical test information. You have, for example, ggAnimate, which allows to have really animated plots over time, for example. ggThemes for some extra themes. We already saw ggRepl and ggpubr, for example. There's gggraph for plotting graphs, and so on. So there's a lot to do, so I would recommend to just have a look at it, try it out, and see what could be helpful for you. So this is a bit of wrap up for the course before we dive into the next part of the exercises, and then later on the case study. You should have learned how to process your data with the tidyverse package, to prepare it for ggplot, how to build basic graphs with it, and how to customize this graph. And I want to give some tips for the future. If you want to use ggplot in the future, it's not a shame to look things up. I have to constantly look things up. There are a lot of resources on the internet, on the reference manuals, on the cheat sheets. Just Google it and see what Stack Overflow says about it, and so on. And if you find some of the examples here in this course or in the exercises useful, you are really welcome to use them, adapt them, change them for your data, and use them in future work. If you want to read a bit further, I already mentioned the R for Data Science book, which introduces also a lot of the tidyverse, the ggplot2 book, and Big Book of R is a website which collects free ebooks for R for different fields and different applications. So just have a look what could be helpful for you. Now please have a look at the exercises 4.3 and 4.4 to practice combining the plots and facets. And after that, you can have a look at the exercises 4.5 to 4.7, which is the case study where we will do a volcano plot with different elements and add also a summary table and a small heat map of the top candidates. This basically combines everything you have learned in this course.